Hi there and welcome to our next lesson in our C3 topic of chemical resources, and today we're going to be looking at batch and continuous product making. So we're going to be looking at different types of the production of chemicals, so whether it is batch or continuous, and look at some of the advantages and disadvantages of those. We'll also look at the production of medicine. Okay, so here are our objectives on batch and continuous processing. So by the end of this lesson you should know and understand how different chemical processes could be made by batch or continuous methods. A batch process is where they make a single amount of a particular chemical. This is very popular in the pharmaceutical industry. Now, pharmaceuticals are where they produce drugs for medicine. Batch processing only makes a small amount of a particular chemical. An advantage of this is the chemical that's being made can be tweaked between each batch and can be changed so that you can get a better product at the end. This is extremely good for pharmaceuticals where you might need to change a particular part of the drug. Now, because of this, the costs are a lot higher. Now, batch processing has some advantages and disadvantages. Some of the advantages include that you can switch the products you're making very easily. So you could be making aspirin one day and then paracetamol the next. You can also meet the demand for particular chemicals. So if you want to make one chemical and it's not selling, you can very quickly switch and make a chemical that is selling. There is also reduced amount of waste product. So if, for example, you are making a drug which has a best before date, you don't have piles and piles of the drugs waiting in a warehouse. The disadvantages mean that it could increase the cost. So things like having a labour-intensive product where you have to maintain the machinery, clean them between each batch, means that costs will be higher. You can only make small amounts as well, which makes it a disadvantage. So you need to weigh up the pros and cons before going ahead to make a particular pharmaceutical drug. Now, with batch processing, they can make about a ton of medicine in a whole year, whereas continuous processes can make thousands of tons of product every day. So chemicals such as ammonia and sulfuric acid are two chemicals that are made via a continuous process. Now, with a continuous process, these can be carried out throughout day and night and all through the year non-stop. Similar to the batch process, the continuous processes have advantages and disadvantages. Because it's continuous, it can run at full capacity all of the time, and because of that it can therefore meet the high demand for the product. Now, because of the continuous nature of it, it has a low running cost, and because there are low labour demands, so there may only be very few staff that actually work for the company producing the chemical. If there is a need for maintenance, then it can slow down production. It might mean that the production has to stop completely, or we have to run the plant at a slower rate, meaning less product is made. The last disadvantage is that only one product can be made, so it has to be specifically designed for that particular product. Now, as we said, medicines are made by a batch process. Now, medicines have a very high cost for their production, and this is due to 6 main factors. The first being labour, the second is the energy cost, thirdly development time, which can be over 10 years from first conception of the idea to actually being available on the market. And that leads into the fourth, which is the research and the testing. Now, as with most things, one of the big costs is going to be the raw materials. And then finally, the marketing and legal costs. Now we'll just have a focus on a couple of these to have a look at why they might be so expensive. Now, the raw materials, depending on what the drug is, for example aspirin, the raw materials are very cheap as they come from willow bark, which is quite a common material. However, other drugs can have quite rare raw materials. Again, they come from plants, and it can be that those plants are quite rare themselves. It also might be that the plants are in a very uninhabitable area, so that it takes a lot of effort to try and actually get the plants ready for extraction of the chemical. Again, the labour costs, because you're doing it as a batch process, you need to have people that are there to change the machinery, adapt it for each batch that you're making. So because of that, you're going to have a high labour cost. And depending on the country that you are in, you're going to have very high marketing and legal costs to be able to produce the drug. And that's set so that we can make sure that the drugs are absolutely safe and good to use. Medicines are produced during a batch process. Now they go through several stages for their production and manufacture. Their manufacturing is synthetic, but they come from a natural source. So it could be a plant, as we've discussed with aspirin and willow bark. Now once you've found a plant material, you need to try and extract the chemical you want. Now the first stage of this is crushing using a pestle and mortar. Now once you've crushed it and the chemical's been extracted from the plant, you can then dissolve the chemical in a suitable solvent. Now if you want to purify that, you can then evaporate the solvent so you get a more concentrated chemical. Finally, chromatography is used to separate and identify the chemical. Now once you've been able to extract the drug, you can then test to see how pure the chemical actually is. And there are a number of tests that you can actually do to find this out. Now depending on the product that you've made, if it's a solid, you can test the melting point. Now if there is a single sharp temperature where it melts, then you're going to have a pure product. Whereas if there is a range of temperature that it melts over, so perhaps you keep increasing the temperature and it continues to melt instead of all melting at one point, then it's going to be impure. If it's a liquid chemical, you can test the boiling point, which is the same as the melting point, where you get a single sharp temperature or a range of temperatures. And then with chromatography, you should get a single dot on the paper, or if it's impure, you get 2 or more dots. Okay, so that's the end of our lesson on batch and continuous production. We have looked at the two processes, batch and continuous. Obviously there are some advantages and disadvantages to both. Remember that with continuous production you are making masses and masses of chemicals per day, which could be 1,000 times more than the batch products are made in a year. Again, we've looked at medicines and where medicines come from and how you can actually extract those medicines from the raw material. Anyway, I hope you've enjoyed this and I'll see you later. Bye bye.